It is late autumn. The light in the garden has thinned to that pale, papery gold that only lasts for a few weeks each year. The leaves on the boxwood are still. The rose canes have gone quiet. And somewhere, tucked between two thin branches at roughly the height of your knee, there is a small, tan-colored object that looks as though someone crumpled a piece of packing foam and pressed it, still warm, onto the stem. Not notice it unless you were pruning. Even then, you might mistake it for a seed pod, or a fungal growth, or, if you have ever raised children, a piece of dried marshmallow that a bird dropped in flight. Move. It does not smell. It does not react to being touched. If you tapped it with the back of a garden fork, you would hear nothing, only the muted thud of something that is somehow both dense and hollow at the same time. Most people encountering it do one of two things. They pull it off and throw it away, or they leave it there, and forget about it by the following weekend. Both of these responses are, in the most literal sense, historic mistakes, because what you are looking at is not debris. It is not packing material, a wasp's nest, or a spider sack, or the residue of some neighborhood child's craft project. It is a fortress, a calendar, a survival strategy older than most of the trees around it, and, most improbably, a container currently holdings somewhere between 100 and 400 living animals, arranged in a spiral, waiting for a signal that will not arrive for another month. Consider the object more closely. Soft, almost lozenge-like, roughly the size of a walnut, sometimes smaller. Its color ranges from the pale beige of unbleached linen to a warm coffee brown, occasionally darkening near the base where it fuses to the branch. Its surface is textured in fine horizontal ridges, as though someone had run a comb across it while it was still wet. That last detail matters. It was, in fact, when it was made. What you are looking at is a foam. Not a metaphorical foam, an actual, engineered, chemically stabilized foam, secreted as a liquid froth from the abdominal glands of an insect, mechanically by that insect's own body movements, and then hardened, over the course of 1 to 2 hours, into a protective matrix roughly analogous to structural polystyrene. Inside that matrix, precisely arranged double column that runs the entire length of the case, are the eggs. This is an ootheca, the egg case of a praying mantis. And everything you have ever been told about the praying mantis, everything you think you know from grade school biology class, or from a viral video of one eating a hummingbird, is a fragment of a much stranger and much older story. We tend to think of the praying mantis as a summer animal, a green, angular predator that appears on porch screens in July, tilts its triangular head at us, and disappears by September when the frosts arrive. This is only about 10% of the truth. It does not disappear in the fall. It simply changes state. The adults die, yes. Most species live for a single season. But the animal, as a lineage, does not vanish. It condenses, compresses itself into the object you are looking at now. And it does something that we, with all our technology, still cannot replicate at scale. It goes into suspended animation inside a hand-built structure, survives temperatures, humidities, and predators that would kill any exposed insect within minutes. What you were taught was the life of the mantis was only the visible chapter. The invisible chapter, the longer one, the more important right now, inside this beige lump on your shrub. And it has been happening, in one form or another, on this planet for approximately 135 million years. Understanding what this object is matters for reasons that extend far beyond garden trivia. The praying mantis is one of the very few large insect predators that overwinters not as a hidden adult, not as a burrowed larva, but as a preloaded population of embryos, sealed in a self-manufactured biopolymer. It is one of the most efficient, most compact packages of predator biomass on the continent. Of ootheca can produce enough hatchlings to control the aphid, mite, and small caterpillar population of an entire backyard for a full summer. When you throw one of these away, assuming it is trash, you are, logical terms, removing several hundred future pest predators from your own property. You are handing the following year's leaf damage to the very insects the mantis was born to eat. And you are erasing an object that, close inspection, is one of the most sophisticated pieces of natural architecture that has ever evolved on land. Begin with the foam itself. The mantis does not lay her eggs first and then cover them. She does the opposite. Extrudes a viscous, protein-rich secretion from paired accessory glands at the tip of her abdomen, and she whips it mechanically using rapid pulsing movements of specialized valves. In laboratory recordings, whipping occurs at a rate of several beats per second for as long as 3 to 5 hours without pause. Is aerated to roughly the same density as commercial expanded polystyrene. But unlike polystyrene, it is biodegradable, waterproof, insulating, repairing at the molecular level for the first several hours of its life. As she whips, she deposits the eggs into the froth in perfectly ordered rows, cementing each one into a chamber before adding the next. When she is finished, the entire structure hardens from the outside into the tough, layered case you now hold. Zoom some out from the case to the eggs. Inside each of those hundreds of chambers is a single fertilized embryo, arranged head downward so that when the moment of emergence arrives, it can push directly through the exit seam at the top of the case without turning. The eggs are not identical. They develop at slightly staggered rates. It's a biological hedge. If the ootheca is damaged, if a bird tears open one end, if a fungus invades one section, the entire brood is not lost. The genetic strategy is spread across time as well as space. Out again. From the eggs to the season, the ootheca is not merely a shelter. It is a thermometer. The embryos inside are held in developmental arrest, a state called diapause, which requires a specific sequence of cold exposure to break. In most temperate mantis species, the eggs need somewhere between 6 and 8 weeks of sustained temperatures below roughly 10 degrees Celsius before they will accept warmth as a hatching signal. In practical terms, this means the ootheca refuses to hatch during a warm November false spring. It refuses to hatch during a January thaw. It waits, quite deliberately. A cold winter has actually been completed, and only then does it interpret rising spring temperatures as real. The zoom out further. From the season to the lineage, the praying mantis belongs to an order called Mantodea, which shares a common ancestor with cockroaches and termites. Fossil evidence, including specimens preserved in amber, places recognizable mantis-like insects in the Cretaceous, existing with the last of the non-avian dinosaurs. The ootheca, the foam case itself, is even older as a strategy. Cockroaches produce a related structure. Termites do not, but their nearest common ancestors likely did. You are holding in your palm is a technology whose prototype was refined while pterosaurs were still overhead. Zop 'em out again. From the lineage to the ecosystem. A single female mantis, lifetime of perhaps 4 to 6 weeks as an adult, may produce anywhere from 1 to 6 oothecae, depending on species and nutrition. Some tropical species produce more. This means that even in a modest suburban yard, a single overlooked mantis in August may be silently seeding the following spring, with more than 1,000 predatory offspring distributed across multiple locations to reduce catastrophic loss. She is not merely reproducing. She is running a decentralized biological warehouse. And zoom out one final time. From the ecosystem to us, for the last 3 decades, material scientists have studied ootheca foam as a model for biomimetic engineering. R combines 3 properties that human industry has struggled to unite. It is lightweight, it is thermally insulating, and it is mechanically resistant to both compression and impact. Research groups in Europe, Japan, and North America have published papers on the internal geometry of mantis egg cases as a template for aerospace composites, medical scaffolding, and cold chain packaging. The insect, in other words, a problem we are still trying to catch up to. There is something quietly humbling about holding an object like this. It is the size of a walnut. It weighs less than a coin. If you set it on your kitchen counter, would look at it twice, and yet, inside it, a population of animals is currently doing nothing. Nothing that a human eye can register, while performing one of the most precise biological calculations in the natural world. They are counting cold time. They are waiting, with a patience that does not require consciousness, for the exact turning of a season. There is no clock inside them. There is no calendar perception. There is only the slow molecular arithmetic of enzymes that will not activate until certain thresholds have been crossed, in a certain order, over a certain number of weeks. Perception. The mantis has been performing this arithmetic, without instruction, without error, without witness, for more than 100 million years. The world is quieter than we think, and busier than we imagine. So return to the garden, to the boxwood, or the rose cane, or the low branch of the lilac, to the small tan lozenge you did not notice a week ago, and might not have noticed for the rest of your life. Look at it again. You are not looking at a lump of foam. You are looking at a sealed vessel containing several hundred living animals in a state of suspended time, tied to perceptions. You had a piece of architecture whose engineering is older than the flowers around it. Perception. You are looking at a promise made in late summer by an insect that is already dead. A promise that if you leave this object alone, if you do not sweep it away in a burst of tidiness, then in the first warm week of spring, in April or May, you will step into your garden one morning and find a soft, translucent cascade of tiny, perfect predators emerging from a slit at the top of the case, hanging briefly on threads of their own making, dispersing, in absolute silence, into the leaves. You will not see it happen unless you look. It takes less than an hour, and once it is done, the empty case will remain on the branch, sometimes for another full year, a small brown monument to something almost no one witnesses. Sit with that, then tell me below. The next time you walked past your shrubs, what did you see that you had missed before? What did you almost throw away? Look again. There is another presence in that same garden, something even quieter, even easier to miss, tucked into the cracks of your stone wall, or clinging to the underside of a leaf. And what it does at night while you sleep is harder to believe than this.